In this video, I'm just going over our practice on our polynomial operations, and there were also a few review with the imaginary unit. So here we're using the two functions of h of x and g of x for these two operations. So based on what's given here in 1a, notice how we have the fraction bar, so we are dividing. When I notice how I'm dividing by g of x is x plus 1. So because my coefficient and exponent are 1, my x is by itself, we can use synthetic division. So I'm going to set up my synthetic division here. So remember, right, change the sign. So this is not positive 1, but the divisor is going to be negative 1. Then here, do we need a 0? Well, 3, 2, 1, no x. So we're good. So the coefficients are 2, 3, 4, and 3. Then remember, right, so first term, we always bring down below. Now multiply. Negative 1 times 2, negative 2, then add above. Here you get 1. Multiply again. Negative 1 times 1, negative 1. When you add above, you get 3. Negative 1 times 3, negative 3 here. When you combine, you get a remainder of 0. That means x plus 1 is a factor. So here, remember, right, when you write your final answer, if we started at x cubed, that means now we're starting with our answer here at x squared. So here our answer, h of x divided by g of x, is 2x squared plus 1x, or x, plus 3. Then the next one, notice how the operation we are subtracting. So we're subtracting g of x, which is x plus 1. Then we're going to subtract from that h of x, which is our 2x cubed. So 2x cubed. Then remember, right, when subtracting, before you start combining like terms, make sure to distribute our negative or negative 1 here to every term. So I'm going to bring down x plus 1, then minus 2x cubed, minus 3x squared, minus 4x minus 3. So notice how what used to be positive is now a negative. Then we can start combining like terms. Well, there's only one x, there's only the x cubed term here, so negative 2x cubed. Nothing to combine here with x squared, so negative 3x squared. But we do have x, or 1x, right, minus 4x, which is negative 3x. Then 1 minus 3, negative 2. So here Molly was trying to find the area of the rectangular. So we're just focusing on the area of this portion here. Well, how do we find area of a rectangle? Length times width. So here, length is 3x cubed minus 4x squared plus 5, and the width is x plus 2. So what are we now doing to find the area? Multiply the two dimensions. So we're multiplying our two polynomials here. So I'm going to set up and do box method area model. So we're going to set this up here. And watch your signs, right? Because that's a negative 4x squared and positive 5. Then x plus 2. So now remember, when multiplying, don't multiply the exponents, make sure to add the exponent. So here for this, you do have 3x, but now if I have 3 and 1, that's now 3x to the 4th. Then here I've got negative 4, but now x cubed, because here we have that 1x here, x squared times x. Then 5x times x is 5x. Then here, 3 times 2 is 6, so 6x cubed. Negative 4 times 2, so negative 8x squared. There's no x here. And 5 times 2 is 10. So now to write our answer, make sure to also combine like terms. Well, I have no other x to the 4th term, so we have 3x to the 4th. Now I do have x cubed here. 6 minus 4 is positive 2, so positive 2x cubed. There's only the 1x squared term here, so negative 8x squared. There's only the x term here, so plus 5x plus 10. So now here, we just need to make sure that when we combine, our like terms. But I do notice that I am subtracting. So we are simplifying but I am subtracting. So before I do anything, I do need to distribute my -1 here. So I'm going to also rewrite so that everything's in standard form. So I've got -8y squared plus 12. Then distributing my negative, so now I've got -5y minus 10 plus 3y squared. So I've got plus 3y squared minus 5y minus 10. So now that I've gotten everything written right in standard form, I can go ahead and start combining like terms. So -8 plus 3, because right, remember we distributed that negative, two negatives make a positive. You end up with -5y squared, not -11. So I'm going to mark off A and B. Then here I've got, ooh, I made a boo-boo. Sorry about that. That's not just a 12, but 12y. Now I've got 12y minus 5y, which is positive 7y, then minus 10. So that's why here the answer was C. Now question number 4 is a little different here, right? So you're given r of x is 9x cubed plus 7. We are simplifying and looking for, well, we're given this polynomial, but plus r of x. So we're finding x cubed minus 4x minus 14 plus, well, what is r of x? Well, r of x is 9x cubed plus 7. Now you're just combining like terms. I've got x cubed or 1x cubed plus 9x cubed, which is 10x cubed. Now I have no x squared. I only have an x term here, so minus 4x. Then we do have -14 plus 7, which is -7. Now, number 5 and 6, we have division because we've got that fraction bar. I notice here my x is by itself, coefficient and exponent of 1, so we can do synthetic division. So again, remember to make sure to change the sign of the divisor to a -4 now. Then let's check to see if we need a 0. 3, 2, oh, notice what are we missing? We're missing the x term. It should be an x here, so we do need 0. So I've got 2, -5, 0, then 2 here. So now we can start that process and bring down that first term. So now multiply below the line, -4 times 2, -8, and add above. Here you get -13. Then multiply again, you will get a positive 52. So when you combine, you still get 52. Then here, when you multiply, -4 times 52 is -208. You get a remainder of -206. That is the remainder. So even just based on the remainder, I can see that my answer is A, but let's just double check. I've got coefficients of 2, -13, plus 52 minus that remainder of 206 over x plus 4. So that's why the answer was A. Question number 6. Now notice here we're dividing by 5a minus 4. Well, because a has that coefficient of 5, we do have to do long division. So let's set up our long division here. So 5a minus 4. Now let's check to see if we need a 0. 3, 2, 1, nothing. So we're good. So we're going to set this up. No 0 was needed because no term is missing. Then now remember with long division, divide the first term into the first term. So 5 goes into 5 one time. We have a cubed, but we're taking out 1a, right? So now we're down to a squared. Then multiply. When we multiply here, we know we're going to match up 5a cubed, but don't forget to multiply, right, to the -4. 1 times -4, -4a squared. Then what do? Change the sign. So this is now negative and positive. So here you get 0, but -9 plus 4 is -5, a squared. Then bring down the next term and we start all over again. Divide the first term into the first term. New first term, -5. 5 going into -5, -1. Now we have 1 less a, so -1a. Then multiply. So here we know we're going to match up negative 5a squared, but don't forget to multiply that negative 1 to negative 4. Negative 1 times negative 4, positive 4a. And again, change the signs before you combine. So now that is a negative 4a. So here we get 0, negative 5 plus 5, but 54 minus 4 is now 50a. Bring down negative 50. Now we divide, but remember, right, first term, 5 into the new first term, which is 50. 5 goes into 50 10 times. Notice how we're taking out the a, so no a is needed. When you multiply, you will get 50a, but don't forget to multiply that 10, right, to the negative 4 here. So 10 times negative 4 is negative 40. Change the sign. So this is now negative and positive 40. So 50 minus 50 is 0, but negative 50 plus 40 is negative 10. So we do have that remainder here of negative 10 over 5a minus 4. So that is our answer here. So now notice this one was a little tricky. Here you are simplifying and combining like terms, but we have b plus 4 to the second power. So the most common mistake is people just, again, want to say b squared and then 4 squared is 16. But that, remember guys, is b plus 4 times b plus 4. So we do have to do box method here to see what our trinomial is going to be. So b times b is b squared, 4b, 4b, and 4 times 4 is 16. And notice we have like terms to combine. So we actually have b squared plus 8b plus 16. And I'm going to continue plus 20 minus 7b squared. Now combine like terms. I've got 1b squared here minus 7b squared, which is negative 6b squared. Then there's no other b term, so plus 8b. Then 16 plus 20 is 36. So that's why here the answer is B. So now number 8. Here you have which term is the fourth term. So when we, here we have a binomial, not just a monomial, binomial, 2x and 5, but being raised to the fourth power. So here we're going to set up our binomial expansion. So with the coefficients of 1, 4, 6, 4, and 1. Then here, remember, right, first term is now a 2x. So I'm going to keep that all together in parentheses as I bring that down. Then we always have our exponent for the first term. We're starting to the fourth power, so 4, 3, 2, 1, 0. And the second term is positive 5. So we now have 5 here. And again with the exponents, but now remember, right, going bottom to the top. So 4, 3, 2, 1, and 0. We are focusing on the fourth term. So 1, 2, 3, 4. So here we're focusing on that fourth term. So don't forget that coefficient of 4, right? So 4 times. Well, that's 2 being raised to the first power, so it's still just 2. And we also have just x here. But we do have times 5 to the third power. Well, 5 to the third power is 5 times 5 times 5, 125. Now notice we need to multiply 125 times 2 and times 4. So here when you multiply, you have 8 here, but times 125, which is 1,000. So that's why the answer is B. Same thing here, you have a binomial expansion, so we're raising to the third power. So I'm going to use the coefficients of 1, 3, 3, and 1. Then same thing, list the term. So here that's just x, so I'm going to bring my x down, then the exponent. Now we're going starting to the third power, so 3, 2, 1, 0. And the second term is a positive 3y to the fourth. So keep that all together in parentheses. And same thing with the exponent. Remember, we're going to go now bottom to the top. 3, 2, 1, 0. And here we're focusing on the third term. So here's our third term right here. Don't forget about that coefficient of 3. So 3 times, well, that's just x to the first power, which is just x. Now be careful, right? Because that is 3 being raised to the second power. 3 to the second power is 9. Then 9y, notice how we have a power to a power. So remember, think about parentheses, right? What do we do when we have the parentheses? Multiply. So now we have 9y to the 8. 4 times 2 is 8. And here, don't forget to multiply 9 to 3. 9 times 3 is 27. So 27xy to the 8. So that's why here the answer was C. This next problem was an extension. So for those who do this one, I am going to go over it now. So you just had to find the area of the picture frame, right? So the picture frame is just all this little section here. So we just need to find the area of the picture frame. Well, technically we have two rectangles, right? I've got here we have 7x plus 8 by 3x plus 1. Well, if we find the area, which is multiplying, right? So if we just multiply and set up here our area model, so 7x plus 8 and times 3x plus 3, keep in mind that you're finding the area of this entire rectangle. So keep that in mind, right, as we're finding the area of this entire rectangle. So this is 21x squared, 24x, then 7x times 3 is 21x, and 8 times 3 is 24. Then when you combine your like terms here, you do have 21x squared plus 45x plus 24. But remember, right, that is the area of that entire. We need to take out, because what we don't need is this section here, right, in the middle. So in order to take that out, we now need to find the area of this rectangle that is inside, which is x plus 2 by x plus 4. Find the area of this, and then what are we going to do then with those two polynomials? Subtract. If we're taking it out, subtract it. So now let's find the area of that inside that we need to take out. So it's x plus 2 times x plus 4. So here I've got x squared, 2x, 4x, and 4 times 2, which is 8. Then when you combine your like terms, you have x squared plus 6x plus 8. So now I've got the larger and the smaller. So now what do? Subtract. So I'm going to subtract 21x squared plus 45x plus 24 minus x squared plus 6x plus 8. Then notice the reason why we need to set it up this way, right, is because when subtracting, we need to distribute that negative or -1 here to every term that we're subtracting. So really, we are combining 21x squared plus 45x plus 24, but with minus that 1x squared, but now minus 6x minus 8. So here you've got 21x squared minus 1x squared, which is 20x squared. Then 45x minus 6x is now positive, so plus 39x. Then 24, but minus 8, which is 16. Then this is the spiral review section here. With the first one, we're just finding the quotient or dividing. Remember here, when you're dividing with your complex number, we need to first know what is the conjugate, and it's in standard form. So we're going to multiply by the conjugate, which is -5 plus 3i. Remember, right? Only change the sign of the imaginary. Then -5 plus 3i. Notice because it's just 7i, we're going to distribute here 7i to both terms. So 7i times negative 5 is negative 35i. Then 7i times 3i is 21, but I squared. Then remember, right, anytime that we have I squared is negative 1. So 21 times negative 1 is negative 21 minus 35i. So just from those signs there, I'm going to mark off A and C. Then remember that trick, our pattern, we're always adding in the denominator. So we're always adding. 5 times 5, or even negative 5 times negative 5 is 25. 3 times 3, 9. So that's why you have a denominator of 34, leaving you with the answer of B. Then number 11, this is again our powers of I. So here you've got negative 8 being raised to the third power, as well as a power to a power here for your I. So here when you've got negative 8 to the third power, you do get negative 512. So again, remember, right, that's negative 8 to the third power, negative 512. And I to the 21. So remember, multiply, power to a power, multiply. Now we can continue and use a quarter method. So when you divide by 4, you get 5 and 1 quarter, 5.25, which is 1 quarter. So this is negative 512, but times I to the first power, which is just I. So negative 512 times I, negative 512i. Then number 12, you are factoring. So here I have my two terms, y squared and a constant, and we have the sum. So we need I because we do have the sum of two perfect squares, no GCF. So here the square root of 4 is 2, so 2y plus. The square root of 121 is 11, but because it's the sum of two perfect squares, 11i times 2y minus 11i. Then question 13, we are finding the solutions. But first, before I do anything, and some people get tricked up, this is the same as, it's just been switched on you. This is the same as x times x minus 16 is equal to negative 80. So I notice I need to distribute my x term here. So x squared minus 16x is equal to negative 80. Then of course, our equation always has to equal 0 because it's a quadratic. So we do need to add that 80 term to both sides. Can't combine it, so x squared minus 16x plus 80 is equal to 0. Now, I cannot factor this, so there are no terms that multiply to get me 80 and add to give me negative 16. I could also notice from my answer choices that we are going to have to use quadratic formula. So remember quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So a, B, and C. So let's first, I'm going to focus on the discriminant to see what we get here inside of our radical. So I've got B squared, which is negative 16 here, negative 16 squared, minus 4 times A, well, A is just 1, times C, which is 80. So now here, when you put that in the calculator, or you get 256 minus 320, you should get negative 64 as your discriminant. So that's how we notice with that negative discriminant, right, we have two imaginary solutions. So that's why we need I. So here I've got x is equal to negative b, so negative b, which is negative 16, plus or minus the square root of our discriminant, which is negative 64, over 2 times a, which is 1 again. Then simplifying, I notice two negatives making a positive, so now we have a positive 16. So 16 plus or minus. Now again, right, don't divide by that 2 yet. Make sure to always simplify that radical. So the square root of negative 64. Well, the square root of 64 is a perfect square. The square root of 64 is 8. So the square root of negative 64, because we have the square root of a negative 1, we need plus or minus 8i. over 2 times 1, which is 2. Now divide. 16 divided by 2, you get 8. Plus or minus 8 divided by 2, which is 4i. So that's why the answer was B.